efficiency. So which is actually similar to the pump setup and the pump if let's say you want to scale up, then you have a similar coefficients or similar formula to do the calculations. Okay, so next. Okay, so in order to scale up or scale down, you will use the equations in the previous page or the previous slide, which is this one. And then after you have done the calculations, then you will have another equations, which is this is for the collections. Okay, so this is for the efficiency corrections. So if let's say after you have done the calculations by using this equation to find out what is the efficiency, okay, because the efficiency probably they will be the same, okay, for the scale up or scale down, then you need to do corrections for it. You need to do a correction for the scale up or scale down turbine. So this is the equation that you are going to use. Okay. Okay, so we will look at one example. So the first turbine is being designed for a hydroelectric dam. Instead of start from a scratch, so the engineers decide to scale up the previous design. So because the previous design has an excellent performance, and then the existing turbine, which is called turbine A, has diameter of 2.05 meter and it spin at 120 RPM, or in terms of omega is 12.57 radian per second, and at its best efficiency point, the volumetric flow rate is 350 meter cube per second, and the head is 75 meter, and then the brake horsepower is 242 megawatt. Okay, and then for the new turbine is having the same spin at the same speed, and the net head is slightly higher, which is 104 meter. Now you need to calculate the diameter for this new turbine, and then need to calculate the volumetric flow rate, brake horsepower, and the efficiency of the turbine. So with all the information given, we can use the equation. We can use these equations to find out what is the diameter volumetric flow rate of the new turbine. Okay, so we just put it in. We just put in the equation. Then with the given diameter 2.05 and the given head, the existing head which is 75 and the new head is 104, and then they are spinning at the same speed. So you will get 2.41 meter for the new turbine. Okay, the diameter for the new turbine. And then we move on to the volumetric flow rate. So since we already know the volumetric flow rates for the turbine A, 350, and then the RPM is the same, and then the diameter, we already have the data from the first calculation. Wait, need to change to the laser point. Okay, so we already have the data from the first question, the first calculation. Then we can find out what is the new volumetric flow rate, which is 572 meter cube per second. And then the next one is for the brake horsepower. The brake horsepower, again, we will use the equation. So they are using the same fluid, which is the water, and then the same RPM. So these two will cancel out each other. Then what remain here will be the brake horsepower of A for 242 megawatt, and then the diameter of the new and the old turbine. Okay, so over here will give you 548 megawatt. Okay, then we will move on. Okay, so then move on, we will check on the efficiency, because the efficiency, usually when you scale up, we will assume that okay, they are having the same equation because the same efficiency. Therefore, we need to do some sort of calculations to do the correction to find out what is the new efficiency. Okay, so this is the equation in previous slide. Then we just put in the existing efficiency, which is 94.2, and then this is the new diameter. Then we can get the efficiency of turbine B. Okay. Okay. Next, we will move on. Okay. So next will be the turbine specific speed. Okay. So if you still remember, we use the specific speed for the for example, the pump specific speed to find out what is the most suitable type of pump for your application. Okay, based on the calculation, based on the flow rate, based on the speed, based on the head and so on. Okay, so this is to calculate what is the turbine specific speed. Okay, so for this specific speed, we will be able to determine what type of turbine is most suitable for the application. Okay, so we will go. Okay, so this is just one example of the turbine. Okay. Okay, so again, because this specific speed it has different different units. Okay, so one is the normal SP, and then we have the for the US the US unit, and the other one, this is the normal one, the SI unit. So please bear in mind when you do the calculation, you need to make sure that you are using the correct how to say, the parameter in the correct unit. Okay, so for example, if you look at here, this is the SI. Okay, so you have the N. This is the N is in RPM, and then this volumetric is in meter cube per second, and this height is in meter. Okay, while you look at here, this is for US, and then you have the height which is in feet, and then this is the brake horsepower is in horsepower instead of kilowatt or watt. Okay, so you need to be careful on this unit. You need to change the unit to the if let's say you want to use the US unit, then you need to make sure that you are using everything in US unit. Okay. 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 Then if you look at here, so you have the specific speed for turbine. This is the T actually is for turbine. And then this is the US unit is over here. This is the scale. And then this is the ST. So you will have the turbine specific speed. So you can have the conversion. So over here, there's no European unit. So there's only the normal one and the US unit. Okay, so whatever below here, this is approximately 0.3. So whatever below 0.3 will be impulse, and from 0.3 to 2 will be Francis, and then from 2 and onwards will be Kaplan or the propeller. Okay. Okay, so let's check on one example. Okay, so need to calculate and compare the turbine specific speed for both small, the A and the B turbine from the example 14.14-15. Okay, so we will check on the specific speed. Okay. So we already have all the calculations from above. Okay. So over here you see the ST. This is the for A. You have the omega, brake horsepower, the rho, the density, and gravitational accelerations, the H and the head. Okay, so this is for turbine A. So your file out is about 1.62. Okay, then you use the turbine B to do the calculation again. Then you will get approximately the same. So it will be roughly here, which is the Francis turbine. Okay, so if you check on here, actually you can see that this is actually is in radian per second. Okay, so is instead of the RPM. So you need to be very very careful during the calculations. You need to make sure that all the units you use for your specific, especially the specific speed, is in correct unit. Okay, so if you put in the RPM here, then you will get a wrong answer. Okay, the RPM is applicable for the US calculation, the US unit calculation, but not for the normal calculation. Okay. Okay. So next, I think just the summary. So we have the reaction turbine. We have so you should be able to calculate to explain the operation, the types of turbine, and then the wind turbine. You should be able to differentiate the types of wind turbine and explain some fundamental operation conditions. And we have gone through the turbine scaling law just now. They should be able to use the dimensionless parameter for turbine design. And then the specific speed should be able to select the most suitable turbine. And affinity law actually is the same as the the pump, as the pump affinity laws is applicable for both pump and turbine. So with the affinity law, you should be able to to find out what is the performance of the turbine with some minor modifications. For example, the change of the diameter and the change of diameter or the speed of the rotational speed. Okay, so with that, I think that would be the end. Wait, let me check on the slide. Okay, I think we have another page of summary. Okay, so this should be the first page of summary actually. Okay, so this is the turbine. In general, the turbine should be able to explain the types and functions of turbine, able to analyze the performance of impulse turbine. For the gas and steam turbine, should be able to discuss the process. So this should be the first page instead of the one we have just now. I think just some sequence problem. Based on current hardware, your wait, okay. Yeah, say that my computer is a bit heavy for my current setup. Okay, so this should be the first page and then come to this page. Okay, so these are the assignment. I think I already uploaded with the slide. So the submission date is mid of next month. Okay, I give you the time until mid of next month. Wait, so we have how many months more? Sorry, we have 3 more weeks, 6, 7 weeks, right? 1, 2, 3, 4, 5, 6. Wait, I need to check on the date again. Um, because this semester you are coming back for a physical exam, so there will be some changes. Yep, I think that should be okay. Okay, so meaning that the given date 15th of July, which is the Friday before you go for your revision week. Okay, so which is the last week of this semester before your revision week. You need to pass up your assignment to the office. Let me share it again. Okay, so this is the date right before your revision week. Okay, so you need to pass up your assignment before your revision. Okay, so far is there any question? I didn't see any questions so far over here. Okay, so for your project, I already have the container or the tank with me, so I will do a little bit of work on it to do some modifications. So the container alone can hold more than 100 liters of water. So I think that should be enough for the test. Okay, based on calculation, it should be able to hold more than 100 liters. So I think that should be enough. Okay, so I will do some modification or some work on it. Then I will set it up or I will put in school, and then I will let you know. Okay, I will update you all. Where I put it, or I will probably put it somewhere safe. Then you can use it to test your pump. Hopefully I can get it done by today. So if let's say I can get it done by today, then I will update you all. Okay. Is it online, right? What do you mean? What do you mean by is it online? I don't wait. Let me check. The wait. Okay. Okay. The pump will be a face-to-face presentation. Yes, it's a face-to-face presentation. The test two will be conducted. The test two, okay, the test two will still be online. My test will still be online, but your presentation will be face-to-face. Your the project will be face-to-face, and your final exam will be face-to-face. What size of paper we use for assignment? It's a A4 size. I think it's normal, right? Back to normal already. Okay, so everything will back to normal. So your assignment will be on A4 paper. Okay, it will or A4 size full skate paper. That's up to you. Okay. Test 2 will be online. Yes. Test will be online. Presentation will be physical. Okay. And your final exam will be physical as well. If I'm not mistaken, your final exam will be only 2 hours instead of 3. But it's a physical one. I think that's still in discussion. Either it's 2 or 3 hours. But I think probably will be 2 hours. And then it's definitely a physical. Yeah, it's a face-to-face exam. So Then you need to make sure, yes, what time is our pump test next Monday? Okay. So next Monday is a public holiday, so I think we can own the whole school. So we can start slightly earlier. So okay, so since our class actually is 11 o'clock, so I think we probably can start at 10. So we can start at 10 and then we can finish up earlier. Okay. So next Monday, 10 o'clock at school. Okay, we will have the presentation. And then right after the presentation, we'll have the test. I mean the testing of your project, your design. Okay. Okay. So if just for your information, if you have a 2 hours exam, physical exam, then most probably the difficult level of your exam question will be far lesser than your seniors. Okay, because your seniors they are having a 3 hours exam, so their paper will be relatively tougher. In terms of number of questions, it's still the same. You have 5 questions, two from Dr. Shariza, two from Injit Yamin, and one from me. Yeah, but in terms of the difficulties, the level of difficulties will be lesser than your seniors. Okay, because they are having a 3 hours exam, you are having a 2 hour exam, so your exam will be relatively easier. Well, will suit to your level at 2 hours lah. Okay. Any further question? Okay, yeah, sure. I will share the link. Yeah, no problem. Okay. So if no more question, then I will see you all on Monday, uh, 10 o'clock at school. Okay. So I will update you all again once the tank is ready. I will set it up or I will put it somewhere at school so that you can use it. Okay. Okay. Thank you. Thank you so much. See you all again. See you next week. Yeah.